Good morning, all. We are live now. Good morning, everyone. I hope you guys can see me. I hope you guys. Hello, good morning. All right. Good morning, everyone. Good morning, everyone. Good morning. We are live again. All right, guys. So we are starting now. We shall be looking at. I'm looking at physics 101. For those of you who are not online, anytime you come online, I'm going to upload this video. All right, for others to actually have access to it. In this class, we shall be looking at friction and laws of motion. Friction and laws of motion. Laws of motion. The laws of motion we are talking about here is simply the Newton's laws of motion. The Newton's laws of motion. So the first thing we need to look at first is we look at friction. We look at friction. Then we are going to look at the definition of friction, the types of friction, application of friction, advantages and what disadvantages. Then we'll see how we can connect all of this with the laws of what of friction. Either so if you are active, please indicate that you are active. All right. We all know what is friction, right? Friction simply means a force of opposition. In fact, friction is a type of force called what contact force, right? Called contact force. Called contact force. I want to believe that we all know that force is an agent that causes motion, right? And force is of two types. We have what we call contact force and force field. Force is of two types, which is grouped into we have contact force and we have force what? force field, right? Force field. Okay. Under contact force, we have a force of push, a force of pull. Then we have friction, right? Under force field, we have gravitational force, gravitational force. We have electric force. We have magnetic force. So many of these, okay? But our emphasis is actually on contact force. And a good example looking at today is on friction. Now, what is friction? Friction simply means a force of opposition. It's a force that tends to oppose the relative motion between two objects in contact. It's a force that tends to oppose the relative motion between two objects in contact, right? That is what we call friction. So, friction is a type of contact force, and in general is a force that opposes the relative motion, okay, between two objects in contact. All right, so we're going to look at the two types of friction, right? The two types of friction. Then we proceed from there. Friction is of two types. Number one, we have the static friction. The static friction. Number two, we have what we call the kinetic friction. The kinetic friction. The static friction is also known as the limiting friction, which is the maximum force that must be overcome. Limiting friction, right? It is also known as the kinetic or dynamic, right? The kinetic. Okay, dynamic rather. Thank you. We have dynamic what? Friction. So friction can be classified into two: static friction and kinetic what? Friction. We'll look at them one after the other, then we proceed further, right? Now, we know the word static. Static is a frictional force that tends to occur on a body at rest. Is a frictional force that tends to occur on a body at rest, or a frictional force that acts on a body at rest. That's called a static frictional force. It's also defined as the maximum force that must be overcome before a body can just start to move overward another body. Alright? It is defined as the maximum force that must be overcome so that a body can just start to move overward another body. That is called the static what? Frictional force. Now, what do I mean by that? If I have a body at first, okay, the body is placed on a rough surface. Definitely, one of the implications of having friction is that the body must be placed on a rough surface, okay, and we can have what we call smooth surface and what a rough surface, right? We can also have what we call rough surface and rough body. If I have, let me explain the three categories of friction. The first one is when we have a body, a smooth body, a body that is smooth, placed on a smooth surface, right? A smooth body placed on a smooth surface. Number one. We can have number two, a body that has a smooth surface but placed on a rough surface. The body has a smooth surface. I mean, the body is well polished, right? Then also the surface is well polished. The second case is a case where the body is smooth and it's well polished, then the surface is rough, right? Number three case is a case whereby the both the body and the surface are what? Are rough. The body itself is rough, has a rough surface, then the surface itself has a rough surface. Okay. Which of these do you think there'll be a maximum static frictional force or maximum friction? Friction will exist more on this body because both the body and what and the surface have what friction. They are both rough. So it means that I will have more frictional force existing in this body because the body rather and the surface are both rough, right? But in this case here, where we have the body itself is smooth and the surface is rough. So there's a less frictional force compared to this, right? And for this, there is a frictional force, but just that it is small. In fact, we have little or no frictional force existing here because both the body and the surface are both what? Smooth, right? Now, what I'm going to say is that when the body is kept in a system or at rest, excuse me, let me lower my record. Okay, guys, so let's proceed. When the body is kept in a system or at rest, I mean, the body is not moving. So, and the body is kept on a rough surface. In this case, we are looking at a case whereby both the body and the surface are both what rough, right? Okay. So, or if a body is kept on a rough surface, that simply means that the body possesses what we call what static what frictional force, right? Okay. So static frictional force is that force that must be overcome so that a body can just start to move over another. And that frictional force Fx is always less than or equals to coefficient of what static frictional force times normal what reaction is always because this force is not a fixed force. This force varies. Let's say, for example, if the frictional force holding this body, okay, on this surface, let's say it is 2000 Newton. Is that not? For this body to move from this point to another point, let's say point B, if this is point A, okay, don't forget that the static frictional force we are assuming is what 2000. That means that for the body to slide over the surface, I must have to apply a force, right, equals to or greater than this. But let's look at a case whereby if we apply, let's say, 1500 Newton force, a force applied is 1500 Newton, and the static frictional force holding this body is 2000. Will the body slide? No. The body will not slide because the static frictional force is far greater than what the applied force. Is that not? So don't forget that at this point, the frictional force that act on this body is what static what frictional force, right? When the body is moving toward this direction, there's a force that tends to oppose it. Static frictional force or frictional force is a force of opposition. If the body is moving this way, if the applied force is this way, let's say we are pushing a car, there's a force that tends to resist it this way, which is called what? Your frictional force, which can either be what static or what kinetic, right? Now, but when the body is at rest and we are applying a force, we keep on applying a force, keep on applying a force, keep on applying a force until the applied force is greater than the static frictional force. Okay, the body will not move, right? But there will be a point whereby the applied force, let's say the applied force here is 2000 Newton. At this point here, where the applied force is now equals to what? The static frictional force of 2000. The body will just begin to move. At that moment, we say we have what we call maximum static frictional force. Our static frictional force is what normally is maximum and is equals to what mu x what r is maximum and is equals to mu s r, which is also equals to the what to the applied force. Listen, let me explain this again. When Fa, the applied force, equals to the static frictional force, At that moment, the static frictional force becomes what? A limiting what? Frictional force, because it is that maximum force that must be overcome. When we started this, I defined gravitational force as the maximum force that must be overcome. That maximum force in this equation is simply 2000, right? That must be overcome so that a body can just start to what? Move over what another. So when the applied force equals the static frictional force, the body will just begin to move. At that moment where the body begin to move, the static frictional force there is maximum and is equals to what? Mu x what? Mu x r. Mu x means coefficient of what? Static or frictional force. R here represent the normal what? Reaction. And the value of R is equals to mg. Okay. R is equals to mg. Okay. Which is the vertical force that acts on the body. Okay. And this force is perpendicular to the surface. After this, I'm going to explain um some motion problem so we can see how we can apply most of these and all that. But what I'm trying to say is that initially, before we have maximum static frictional force, where Fa is equals to what? Fr. The static frictional force is always a range of value because the applied force, you keep on applying the force, right? It is not a fixed value. So from here, we say that Fs is less than or equal to what? Mu x what? R. Why are we saying it? Because the frictional force, the static frictional force is not fixed. It's not fixed. It's not fixed. If it's fixed, I will have just used a particular force and overcome it, right? But because it's not fixed, we'll keep on varying the force. Is that clear, somebody? So because the force is not fixed, so we have Fs is less than or equals to mu x what R. But don't forget that we say that R is also equals to what? Mg. Okay. Now let's look at um kinetic what? Frictional force. Kinetic frictional force. Hope my explanation is clear, right? For those of you who are online, hope you are getting the explanation. I'm trying to make it so simple so that we can all get it. Okay, let me check. Okay, now we are saying that, listen, if I have this, a body kept here, right, and the body has a certain mass, the weight of the body will always act downward, right? We have weight equals to what? Mg. We are looking at a case where we have friction along this path, right? Then when we have this, we have our fx, then we have here to the what? Fa, right? Okay. We're looking at the body. When the body is kept at rest, right? The body is kept at rest. Okay. We say that when the body at rest, when the body that is not in motion, that is the frictional force that held that body is what? Static what? Frictional force, right? And I define that the frictional force Fx is less than or equals to what? Mu x what? All right? Where R is equals to what? Mg. So Fx is less than or equals to mu x what? Mu x mg. Is that not? Then when the applied force is equals to the Fs, we say that we have the maximum static frictional force, right? We have the maximum Fx maximum, Fx maximum, which is equals to what? Mu x what? R, right? Also equals to mu x mg. Is that clear? This is when the applied force, right, is equals to what? The static what? Frictional force. So then we have the maximum static frictional force overcome. Now, what about the case whereby the applied force is greater than the static frictional force? Is greater than, right? Look at this case here. When Fa is equals to Fx, we have overcome the maximum. So we have Fs maximum, which is what? Mu SR. But what about the case where I keep on applying, let's say the frictional force here is 2000, and I kept applying a force, okay, a force greater than 2000. What will happen to the body? The body will start moving. The body will start accelerating, right? Okay. Now, if the body start accelerating, the body start accelerating, the body is in motion. Listen, the body can only be in motion when they apply force, right? When they apply force, Fa is greater than what? Fs. If not, the body will not move, right? Okay. So when Fa is greater than Fs, the body will be in motion. Then the frictional force will be converted from static to what? To kinetic, because the body is now in motion. The body is now in motion. The frictional force will be converted to what? To kinetic. Instead of having Fs, we will now have what? Fk, right? So to find the acceleration of the body, because at this point the body is now accelerating, I can determine what somebody the acceleration of the body along the x-axis. The body is moving along the x-axis, along the horizontal axis. So the sum of all forces here along the x-axis is simply the applied force minus the frictional force, right? The frictional force. But let me define the frictional force. Look at the side of the board. If frictional force, if maximum static frictional force is given as mu SR, that means that our kinetic frictional force is equals to mu K R, right? So our Fk is equals to what here? Mu K what? Mu K what? Yeah, mg, right? Mu K mg. But here we are looking at a case whereby the applied force is greater than what? The static frictional force. So if this should happen, that means that the body will start accelerating, right? Now, if you look at this, along the horizontal axis, the body is accelerating. We have just two forces acting along the horizontal axis. There are other forces here. We have the weight of the body acting downward, which is mg. We have a force here acting upward, which is what? Normal what reaction, which is what? Mg. For a body at first, a body not moving, the weight of the body is always acting downward, which is W equals to what? Mg, right? Then there's a force called the normal reaction, which is equals to what? Mg. R equals to what? Mg. Most of the time we use N. N equals to what? Mg to represent this as well. Is that clear? Okay. So we also use N to represent our Mg as well in most cases. So what I'm saying here is that when the applied force is greater than the static frictional force, the body will start accelerating along the horizontal axis. But we have two forces that act along the x-axis, which are the applied force and the frictional force. The applied force is acting towards the direction of motion, doing a work, right? For a work to be done by the applied force must act in the direction of the displacement of the body. So if the body is being pushed this way, that means displacement is going this way. So there's a positive work done by the applied force because the applied force is acting in the same direction of displacement of the body. But the frictional force there is doing a negative work because it is acting against um, against the displacement. Okay, so that means the angle between the applied force and displacement is simply zero because they are both acting in the same direction. Then the angle between the frictional force and displacement rather is 180 because they are acting in opposite direction. I'm taking us back to vectors. Now, when two vectors are acting in the same direction, right? That means that the angle formed between them is 0 degree. So from there we can determine their resultant, which is resultant equals to the sum of the two vectors. But when two vectors are acting in different directions, it means the angle formed between them is simply 180 degree. Okay, this is the case here whereby we have an applied force. We have two forces along the x-axis. We have the applied force, we have the frictional force, right? So the body is being displaced because the applied force is this way. So that means that the applied force is in the same direction with displacement. So doing a positive work, right? Why this is doing what a negative work? Now, any force that acts towards displacement or towards acceleration of the body is always what positive, because that force is doing a positive work, right? Any force that acts against displacement or against um, acceleration is doing what a negative work. That's why we are saying that the sum of all the horizontal, the sum of all the horizontal what? Horizontal force, sum of all the horizontal forces, and is given as what? Let's repeat this concept again. Is given as sum of all horizontal force equals to the applied force is always positive because it's doing a positive work. Any force that acts in the direction of motion, if a body is going this way, right, that means the applied force and motion are in the same direction, or the applied force in the same direction with what displacement. So it becomes positive. Minus the frictional force is doing a negative work, is acting against acceleration. Okay, the ball is this way, this force is always acting against it. So it becomes what? Minus what? Fk. All equals to what? Mass times what? Acceleration, because the sum of all forces, according to Newton's laws of motion. This is where Newton comes in now. Newton's second law of motion, which is called the law of acceleration, right, of a body. Okay, now if we have this, the law says that force equals to what, right? Mass times what? Acceleration. I mean, the rate of change of momentum is equal to the applied force, right? And all that. So from there we have this. That means the sum of any forces along the x-axis will then be mass times acceleration along what? The x-axis. But if I'm considering vertical motion, let's say a body is going up, okay, then this will be what? Sum of all what? Vertical forces, right? Equals to what? Mass times acceleration along what? The vertical axis. But here we are looking at horizontal what? Forces, right? Horizontal forces, which are the applied force and what? The frictional force. So that means that here becomes our Fa minus what? Fk equals to what? MAS. So from here, I can determine my acceleration. So I can divide both sides by what? By mass, right? By mass, just to find the acceleration. That means my acceleration becomes what? Somebody, the applied force minus the frictional force divided by mass. Divided by mass. Please don't forget. Divided by what? By mass. Okay. This is for a body accelerating along a rough surface towards a positive direction. Okay. Okay. So to find the acceleration, we have the applied force minus what? Frictional force. The kinetic frictional force, all divided by what? M. Don't forget that this is also same as what? Applied force minus our frictional force, Fk. We said is what? Mu k mg. Coefficient of what? Kinetic frictional force, mu k mg, right? All divided by what here? Mass. All divided by what? Mass. Okay, let's take note of this. Very important. Then I would like to state Newton's laws of motion so that we can have this simultaneously. Let's just learn both of them simultaneously and see how we can apply. The first law of motion is called the law of inertia, right? It's called the law of inertia. Second law is called the law of acceleration. The third law is called the law of action and what? Reaction. Exactly. Now, the first law says that a body will remain at rest, right? Or in motion unless acted upon by an external force. A body will remain at rest or in motion unless acted upon by an external force. Like what we saw here, this body will remain at rest if not that there's a force applied, right? You can see how friction is interconnected with what? Newton laws of motion, right? They have a relationship. So here is telling us that this body will remain at rest we keep on having a static frictional force unless a force is what is applied to change the frictional force to what kinetic. Is that clear, somebody? So a body will remain at rest or in motion unless acted upon by an external force. That means when the body is set in motion, what will keep a body from um, stopping is what somebody is the law is inertia, right? The property acquired by the body to always resist change in its state of what? Of motion. Are you there? Okay. So let's look at, I want to show us a case here. Look at this case we looked at before we go into the second law of motion. Something just came to my mind. I would like us to look at this very well. It's very important we talk about this. Now, what about a case? We spoke about, I want to remind us something very important. We talked about when the applied force is equals to what? The static frictional force, right? When these two forces are equal, we say the body will just start to move. So the body possesses maximum static what? Frictional what? Force, right? Then we spoke about when the applied force is greater than what? The static frictional force. The body here will gain what? We gain kinetic, right? So the body will start accelerating. And we say that to find the acceleration of the body, well, we have to use Fa minus Fk divided by m. What about a case whereby the applied force is equals to Fk? When Fa is greater than Fs, right? The body now possesses what? Fk. What about when Fa is equals to Fk? If the applied force is now equals to the acquired kinetic what? Frictional force, what do you think will be the result? Now let's watch. If these two are equal, that means the body will start moving with a constant velocity. There's no acceleration, all right? When the applied force and the kinetic frictional force are both equal, the body will move with a constant velocity. Okay, so just know that when the applied force is equals to what? Kinetic frictional force, the body moves with constant velocity, right? At that moment, acceleration on the body along the x-axis is equals to 0. Don't forget that we say that recall that sum of all these forces is equals to what? The applied force minus the frictional force, right? All equals to what? Mass times acceleration. That means the sum of all these forces here, or rather, that implies that the applied force minus frictional force is equals to what? Mass times what? 0. So from here, can we say that this is same as Fa minus what? Fk equals to 0. If this is equal to 0, I can move my minus Fk, right, to the other side. So that means the applied force is equals to what? The kinetic frictional force. Now, when these two are equal, that simply means the body is not accelerating. It means the body is moving with a constant what? Velocity. Please take note of this, all right? Okay. Now, Newton's second law of motion is the law of acceleration. The law says the rate of change of momentum of a body, the rate of change of momentum of a body, right, is proportional to the applied what? Force. It's proportional to the applied force. So the law says that the rate of change of momentum, rate of change of what? Momentum equals what? Applied force. Equals applied force. Meaning our rate of change is simply mv minus u divided by what? T. Is proportional to the what? Applied force. Or it is directly proportional, right, to the applied force. We have what called direct proportionality, indirect. For direct, we have inverse, right? We have joint. This is a direct relationship, right? So let's look at this. So I can also say this my force is proportional to what? M V minus U divided by what here? By T. All right. So recall that. Okay, from here, rather. To take off this sign, I have to introduce a constant, right? Introduce a constant and also an equal sign. That means my force is equals to what here? Km V minus U, all divided by what here? T. Okay. Now, to define the force, I will set the value of K to be equals to what? 1. I will set the value of K to be equals to 1. So that means my force F equals to what here? M V minus U divided by what? T. But don't forget that we say that acceleration is change in what? Velocity, right? Over what? Over time. A is V minus U over what? T, right? So I can replace the whole of this here with A. That means our F is equals to what? M what? A. Now, are you seeing what the law is saying? That acceleration on the body depends on what? On force. That means if we increase the force, it will also increase what? The acceleration. Both of them are directly what? Proportional to each other. So increase in force applied must increase the acceleration of the body, right? Also, increase in the mass of the body will also increase the force applied. The more the mass, the more there will be a greater force that will be applied to move the body from one point to what? To another, right? Because if you look at this law has a connection with the first law, which is called the law of inertia. Inertia talks about the mass of a body. Inertia, inertia talks about the mass of the body. The more the inertia, the more the mass of the body. In fact, inertia and mass are directly proportional, meaning that increase in the mass of the body leads to what? Increase in what? In inertia. Inertia is the property acquired by a body, right? So always resist what changes. So if this mass is increased, it will definitely increase what the inertia. Then it will also affect the force applied, which is also increase because increment in the mass will lead to increase in force, right? Why increase in force will lead to what? Increase in what? Acceleration. So this is just what the second law is talking about. Now let's look at another concept. I hope you guys are following, right? Okay, let me check. Sorry, be sure. Okay, that is awesome. If you are following, please indicate that you are following. Please, if you are following, indicate. All right, so let's continue. We are combining all this knowledge together so that we can be able to maximize. So while we are solving any problem, we can have a full understanding of what is all about. Okay, let's look at a case here, a very sensitive case. A case where we let's say we have a body here. Please pay attention. The body is kept here. Don't forget that when the body is kept on the surface, right? The weight of the body is always acting downward. The weight is mg. There's a force here, always acting what? Upward, which is what? Normal reaction, right? R equals to what? Mg. Are you there? Okay. All right. Okay, let me bring this out this way first for us to compare them together. Let me bring this out here. If I have a body here, the weight is acting down. The weight is equals to what? Mg. There's a force here, right? Which is called the normal reaction. Always acting up, which is R equals to what? Mg. Then we are looking at a case where we have a rough surface, right? Okay. Then if we apply the force here, the applied force is here. Here we have our frictional force, right? Okay. When the applied force is greater than the frictional force, we agree that the sum of all these forces is simply what? The applied force, right? Minus what? The kinetic frictional force. Because if Fa is greater than what? Fx. Let's say we have Fx. Definitely the frictional force becomes what? Kinetic, right? So the body will start what? Will start accelerating. Is that not? Then we say that our acceleration of the body is simply Fa minus what? Fk over what? Over m. But we now say when the applied force is equal to what? Fk, right? That means our acceleration is 0. Exactly? It means it's 0. Okay. So from here we can put the value of a as 0. So that means at the end of the day we have Fa equals to what? Fk. Now, what about a case where we have a smooth surface? This is for a rough surface, right? And some of you will be asking, what of a smooth surface? If I have a smooth surface where there is no frictional force and the mass is kept here, and I'm to move this mass, I'm applying a force, okay, towards this direction of motion. I'm pushing this body towards this direction on a smooth surface. That means there is no frictional force. We don't have anything static or what kinetic. They are very minimal or 0. Okay, so that means the only force acting on this body along the x-axis is simply what? The applied force. Although we have our vertical force, right? The weight is W equals to what? Mg. While we have the normal reaction, R equals to what? Mg. So the only force, the sum of all forces here is simply what? The applied what? Force. The sum is only just the applied force because we don't have the frictional force here. So if I have a frictional force, I will have said minus. Do you get the concept here? But since the only force is applied, so that means the sum of all the horizontal force that causes the body to move or that do a positive work on the body is simply what? Fa, which is all equals to what? Ma what? X. So from here I can find my acceleration, which is my Ax equals to what? The applied force divided by what? By m. If Fa equals to mas, that means we'll find the applied, we'll find the acceleration. We divide both sides by what? By m. Divide both sides by what? By m. By m. So mass can cancel mass. So we are left with acceleration equals to what? The applied force over what? The applied force over the mass of the body. Alright, so that is just what I want to show us. But let's look at when we have a system of a body along the horizontal axis, but the body is being dragged with a rope. The body is being dragged with a rope. The body is being dragged with a rope. Let's look at this together. If I have a system of a body like this, okay, then we on a rough surface, don't forget the weight of this body is always W equals to what? Mg, right? In this case, there's no applied force here. There's no force here. We have a rope here that is being used to drag what? The body. And the rope has what we call the tensional force, right? The force that acts on a rope is what? Is tension, right? So we have this ball is being dragged with a certain angle called what? Theta along the horizontal. Along the horizontal. Okay? Along the horizontal. It's being dragged this way. Let me maintain my horizontal surface. Then we have okay, let us go this way. Alright, so if we have an angle called what here? Theta, and we have our tensional force here. Don't forget that we are dealing with what? A rough what? A rough surface. That means there must be frictional force present, right? This frictional force will definitely be acting this way. It will act in the opposite what? Direction. The frictional force will act in opposite direction. Don't forget. But in this case, there's a force that acts upward, which is called the normal reaction. But normal reaction here is not equals to what? Mg. It's not equals to mg. I will explain why. If I have a body like this, where there's no rope attached, they say the work done, the weight rather is mg, while normal reaction is what? Somebody? It's also mg, right? For a body, a system of a body in this kind of diagram, your normal reaction equals to the weight of the body, right there. Then the upward force equals to the downward force. What is normal reaction? Normal reaction is simply the force, the surface, the force the surface is exerting on the body. The body is exerting a weight, is exerting a force on the surface. Like when you sit on a chair, okay, you are exerting a force on the chair. That force you are exerting on the chair is called the weight of the body, because the force is acting down. If this is you are the body, right? This is the surface. As you sit on this surface, you are exerting your weight downward. Now there's a force the surface is exerting on the body. So the force the surface is exerting on the body is called the normal reaction, which is always acting downward. You can take note of this in case you have to define normal reaction. Normal reaction is the force, okay, is the force a surface exerts on the body, right? While the weight is the force the body exerts on the surface. So if we have a diagram like this, where we have a rope, it's like I'm dragging a body along the x-axis, right? Okay. In this case here, this force here, T, can be resolved into two components. We have our tensional force. So let me complete my diagram. My tensional force is here. I'm dragging a rope. I'm dragging a body with a rope. Okay. So this, as long as there's an angle of inclination here, I can resolve this force into two components, meaning that it is not just this force that is acting on this body. We have two forces here. We have what called the vertical force, which is our Ty, and what again? We have our Tx, right? We have our Tx. These two forces, the sum of these forces is equal to what? This is the resultant force. What's the resultant force? Is that single force or vector that has the same effect, right, in magnitude and direction as two or more forces acting well together. That means these two forces, Ty and Ts, summed up together will give us what? The resultant force. So if I should apply a rope on a body, I'm not just applying the rope, I'm dragging the body along the horizontal at the same time along what is vertical. Okay, that is just it. So why do we say that normal reaction is not equals to what? Mg? Because there's a force called Ty here. This Ty is supporting the normal reaction. So look at this here. I don't have any rope here. There's no rope, right, supporting this body. So the force acting up equals to the force acting what? Down. But for this body, why do we say they are not the same? Because Ty is supporting this. So we have two forces acting upward. which is what? Normal reaction and what? And Ty. Then we have one force acting down, which is what? The weight of the body. Now, how do we define the formula for R? If the value of R is not equal to mg, then what is R? What is normal reaction if it's not equal to mg? Now, let's define that here. Listen, to define that, I will have to say that the sum of all upward force, upward forces equals what? Downward what? Downward forces or downward force. How many force is acting upward? Is simply Ty and what? And normal reaction, right? How many force is acting downward? Is just one, which is the weight of the body. So that means that normal reaction plus what? Plus Ty is equals to what? The weight of the body. So for me, I can say normal reaction is simply the weight minus what? Ty. Now, are you saying that by the time we evaluate this, normal reaction is simply greater than what? The weight? Of course, because this force here is supporting normal reaction. So we are subtracting a fraction of Ty from what? The weight of the body, which makes the weight less than what? The normal what? Reaction. So the formula for finding normal reaction for a system like this is simply how equals to what? The weight minus what? Mg. Don't forget that the weight remains what? Mg, right? Weight minus Ty rather. How equals to weight minus Ty. Don't forget that the weight remains what? Mg. So how equals to Mg minus Ty. Now, another thing I want us to define is the resolution of these forces. We have Ty and what? Ts. I want to believe that we all know how to resolve, but I'm still going to explain vector resolution because tension is a vector, right? It is a vector of cells, so we can resolve it. We can resolve it, okay? Look at this here. Listen. If you look at it, in vector resolution, whenever your angle of inclination is along the x-axis, we can resolve Ts using cosine. The trick to resolve Ts is cosine. The trick to resolve Ty is what? Is sine. Okay, is sine. So let's look at this now. Since the angle of inclination is along the horizontal axis, so in vector resolution, we can say that our Tx is simply T cos what? Theta, equation 1. While Ty will be T sine what? Theta, equation what? 2. If the angle, let's say we have a diagram like this, like this, okay, and my tension is here, and the angle is somewhere here, the angle is now along the vertical axis, are you there? So there's no way I can resolve it the same way. My Ts becomes what? Our Ts becomes T sine theta, while Ty becomes what? T cos what? Theta. I can further explain this so for further understanding or for better understanding rather, for better understanding. Let me show us something briefly. If I have this here, I have this, right? I have my angle of inclination. Here we have our tension. Here we have Ty, and here we have what? Our Tx, right? I want to resolve this force. I want to resolve Ts. I can only resolve Ts with respect to what? T. Using the word SOHCAHTOA, from the word SOHCAHTOA. Let's say I'm considering my Ts. Ts is the adjacent, Ty is the opposite. While tension, the resultant here is what? The hypotenuse, right? But any side that faces the angle is called the opposite, so which is my Ty. So Ts is adjacent, T is what? Hypotenuse. So to resolve my Ts with T, I will use CAH, right? So I will say using cos theta. So we have Tx divided by 1 by T. So we can actually cross multiply this, right? That will give us what here? Our Tx equals to what? T cos what? Cos theta. Are you there? So to resolve our Ty, I will resolve Ty with T. Ty is in the opposite, right? T is still what hypotenuse. That means I can use my sign to resolve. So I will say sine what? Sine theta equals to what? Opposite over what? Hypotenuse. What's the opposite? Is Ty. What's the hypotenuse? Is T. By the time we cross multiply, Ty times 1 is Ty, which is equals to what? T sine what? Sine theta. Are you seeing it now? That in vector resolution, whenever the angle of inclination is along the horizontal, resolve your Tx, the horizontal component will take the trig cosine, which is what T cos theta. While Ty will take the trig what sine, which is what T sine theta. Now we now know better. Now let's see how we can evaluate further, right? Okay. Now look at this now. We have been able to state that the normal reaction for this diagram is not equal to mg, right? Because we have a supporting force here, which is our Ty that acts vertically upward. Ty is supporting the normal reaction. So the sum of the upward force is normal reaction plus Ty, which is equal to the weight of the body, the downward force. And we have seen that normal reaction is W minus what? Ty, right? So yeah, R is also equal to what? Mg minus what? If our Ty is T sine theta, here will be what? T sine theta, right? I repeat again, R equals to W minus Ty. The value of R is mg, which is the weight. Ty, we have resolved it as what? T sine theta, right? So let's take note of this expression. So let's look at the sum. The sum of all horizontal forces. Now let's look at this. Along the horizontal axis, how many forces? We have seen that we have 3 forces along the vertical axis, which are normal reaction, Ty, and weight. How many forces do we have along the horizontal axis? Just 2. We have our Tx, and we have what? The frictional force, right? Ts and what? Frictional force. Look at this here. The direction of motion is this way. Before you determine which of these forces is doing a positive work, you have to look at the direction of motion. Any force that acts in the direction of motion is doing a positive work. So if I have 2 forces along the horizontal axis, which are Tx and what? T and what? Fk. Ts is moving in the direction of what? Motion. While Fk is moving against what? Direction of motion. Okay. So that means that our Ts becomes what? Positive, while Fk becomes what? Negative, because Ts is doing a positive work, then Fk is doing a negative work. Now let's go. So that means the sum of all the horizontal force will be Tx minus Fk, all equals to mass times acceleration along the horizontal axis, right? Okay. From here we can determine our value of acceleration by dividing both sides a bit. I can say divide both sides by the mass. That will give us our Tx, our acceleration rather. By the time we divide by mass will cancel mass from here. So we are left with acceleration along the horizontal axis, right? Which is equals to what? Tx minus what? Fk divided by what? Mass. So acceleration along the x-axis then become, don't forget we say that our Ts is simply T cos theta. So let me put the value. We have our T cos theta minus our Fk is mu k r. Fk is mu k r. From what we define friction as, we say friction generally F equals to what? Mu r, right? So if I have my kinetic friction, that will give us what? Mu K what? Mu K R, right? But for this, don't forget that the value of R is not equal to mg. We have already defined this R as what? Mg T sine theta. The only time I can use R as mg is when we don't have a system like this. Okay, when we have a body just along the horizontal axis. Are you there? But if I have a system like this, I can't uh, take my normal reaction to be equal to what R. So from here, I can say divided by what? By mass. I can put the value to further expand this. Let's go. Here becomes what? T cos theta minus mu K in bracket. Normal reaction here becomes what? Mg minus T sine theta. Mg minus T sine theta, right? Okay. All divided by what? By mass. All divided by what? By mass. We can further expand again. Acceleration of the body becomes T cos theta minus mu K mg minus mu K times mg is minus mu K mg minus mu K times T times theta will give us plus mu K T sine theta. All divided by what here? Mass. Okay, let's see what we can do. If you look at this expression here, I can also stop here. I can stop here. All we just need to know is once you can be able to get your figures, just input a value. Okay, then that will be done. But let me see what else can be done here. Here we can have, let me go through this again. Here we have this. Okay, Ts mu K R perfect, mu K mg minus T sine perfect. Okay, we have mu K mg plus mu K T sine theta. So let's take these two as like terms, right? As like terms. Why? Because both of them have tension. So I can say this is equals to what? T cos theta plus mu K T sine theta minus mu K mg, right? All divided by what? N. So from here, we can actually make our T to stand alone as the subject of the formula. Then we can find the acceleration. Okay, let's look at any of this formula. Please don't be confused. I hope you guys are following. I can start from here. We can, if I'm solving, I can solve for my normal reaction first, right? So if I'm to solve for my normal reaction first, that means I don't need to go through this process here. I'll just put the value of my normal reaction already solved. Is that not? Then the value of mu K will be given definitely. Then the mass will be given, right? Tension will be given most of the times. Then your angle of inclination will also be given. So all of this, I'm just showing us how to expand and all that. So let's take note of this. Let's look at what we call the laws of friction. The laws of friction. The laws of friction. The laws of solid friction. Number one is that friction opposes motion. Friction opposes motion. Number two is that friction is dependent on the nature of the surface in contact. Nature of the surface in contact, right? Number three is that friction is independent on the surface area. of the object in contact is independent on the surface area of object in contact. Number 4 is that the force of friction, the force of friction increases okay, increases to the same extent, to the same extent as the force which tends to start the motion. Number 5, frictional force. Frictional force is directly proportional, directly proportional to normal reaction. Normal reaction. All right. Laws. These are the major 5 laws of friction. The first one says friction opposes motion. When a force is applied, there's a force that tends to oppose, which is called friction. Friction is dependent on the nature of the surface of contact. When we started this class, I gave us the three categories of what of surface, right? That it depends on the surface of the body, surface of the object itself, surface of the ground floor when the body is kept on the ground floor, right? So it depends on the nature of the surface, if it's either rough or what or smooth. Is that not? Number 3 is that friction is independent on the surface area of the object. No matter how large the body is, no matter how large the surface area is, it does not depend on the surface area. Frictional force increases to the same extent as the force which tends to start the motion. We saw that when we explained, I say that when we have when the value of FA, right, is equals to what Fx, we are going to have what the maximum static force, static frictional force, right? This is what is explaining here. The force of friction will always increase to the same extent as the force which tends to start the motion. Then the last one says frictional force is directly proportional to normal reaction. Frictional force is directly proportional to normal what reaction, right? Okay. By the time I take off this sign, that means our frictional force is equal to what? Mu k what? N, right? In some cases, they use N, or they use what? R. Okay, all of these are the same, which is all equals to what? Summary mg. So I can also use my arrow here, right? So I can say F equals to what? Mu what? Mu R. Okay, so the value of F is equals to what here? Mu mg. Where the word mu here represents the coefficient of friction, right? It means coefficient of what? Of friction. It means coefficient of what? Of friction, right? Okay, so we now define the 2 types of friction. That if we have static friction, is always less than or equals to what? Mu x mg, right? Then when we have a maximum static friction, where the applied force equals to the Fs, right? We're going to have what to the here? Mu x maximum equals to what? Mu x mg. Then we'll say that the second rather, types of friction, which is the kinetic frictional force, is always Fk equals to what here? Mu k mg. Please don't forget this, all right? Mu k what? Mg. Okay, now we have seen the laws of friction. Let's look at the advantages of friction. Friction makes walking possible. Friction makes walking possible. Without friction, it is practically impossible to walk. Okay, that's the first advantage of friction. Number 2 is that friction is being used in the grindstone to sharpen chisels and knives. Number one is that friction makes walking what? Possible. Number two is used in the grindstone to sharpen what? To sharpen knives, right? Knives and what? And chisels. Knives and chisels. Number three, right? We have so many advantages of friction. One is that it makes working possible. It is used in grindstone to sharpen what? Knives and what? Chisels, right? Okay. Please give me in the comment section for those of you who are online. Please indicate if you're online. Wow, indicate if you're online. Who can tell us other advantage of friction? Other advantage of friction. Let me know those of you who are active. Other advantage of friction. I'm giving you guys 1 minute to type in the comment section. Apart from friction making work impossible, friction being used in the grindstone to sharpen knives and chisel, what are the other advantages of friction? Other advantages of what? Friction. Okay? Anybody in the comment section? I'm waiting. Anybody in the comment section? What are the other advantages of friction? I was expecting you guys to tell me one or two. Friction is used in the application of brakes, Abi. It allows a brake to be applied. It allows a brake to applied. To be applied. Someone is asking the question that what is R? What is R? I just saw a question in the comment section. What is R? We say R represents what? The normal force, Abi, or normal reaction. Normal reaction. And I explained this during my class, except you are just coming in now. We talked about the normal force or normal reaction, that if I have a body kept on a surface, right? Okay, on a rough surface, the weight of this body is acting this way, Abi. The weight is always acting this way. Like let's say you are sitting on a seat or on a bench, right there. Your weight is always acting downward. You are um imposing a force, right, on the surface of the bench. So your weight is always acting downward. Now there's a force that is always acting upward. The force the surface exerts on the body is called the normal reaction, which is always acting what? Upward. I repeat again. The force the body exerts on the surface is called the weight of the body. But the force the surface exerts on the body is called the normal reaction, which is equals to what? Mg for this diagram. Please go to the lecture, the notes, the class rather. You will see where we analyze the value of R equals to mg and R equals to um, weight minus weight. R equals to weight minus what? Minus Ty. We analyze this. Make sure you go to the class and you see where I explain the two conditions or the two ways we can express R for today's class. R equals to mg or R equals to what? W minus what? Ty. But just note that your normal reaction is that force the surface is exerting on the body, while the weight of the body is the force the body is exerting on the surface. Right? Okay. Now we have seen the advantage. It makes working possible. It is used in a grindstone to sharpen knives, to sharpen chisels. Is that it allows a car to apply, or yeah, it allows the brake rather to be applied, right, to a moving car. Without friction, we cannot apply a brake to a moving what? To a moving car. Okay. Disadvantages of friction. Disadvantage of friction. We should know this. Disadvantages of friction. One is that friction slows down motion, right? It slows down what? motion, or it reduces motion, right? Number two is that friction causes wears and what? And tears. Number three, friction reduces speed, right? The speed of a body in motion, which is almost slow down motion. Oh, this the first and the third are the same. Number three is that friction causes heating of engine, right? Heating of what? Of engine. We have many disadvantages of what friction. Please, you can indicate more of this in the comment section. For those of you who are active, please, what are the other disadvantages of friction? 1 minute, 1 minute, 1 minute. What are the other disadvantages of friction? What are the other disadvantages of friction? Okay, someone already commented that it allows the brake of a vehicle to be applied. That should be advantage, right? Then someone else comments that it holds shoes on our feet. Awesome. That's also a good advantage. It helps to hold shoes on our feet, right? Even there's another advantage is that it allows, it makes writing possible. It makes writing possible. Writing possible. Without friction, you can't be able to write on a paper. So these are the advantages. How do we reduce friction? 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 Okay. Number one by polishing. Polishing means we are making it to be smooth. Okay, because friction acts on a rough surface. So when you polish the rough surface, we can reduce friction. Number two is streamlining like the shape of aeroplane to overcome the air resistance. Number three, we have banking of roads, banking of roads. Number four, we have polishing, we have streamlining, we have banking of roads. What other method do we use to reduce friction? Okay, application of lubricants, lubrication, etc. Okay, so please indicate in the comment section other method that can be used to reduce friction, or you can make more research on this to get other method of reducing friction. But we know we have polishing, we have streamlining, we have banking of roads, we have lubrication, right? Applying of lubricants on a rough material, on a rough surface. This can help to reduce what? Friction. Okay. Now, I want us to solve some problems, some challenging problems on this, some challenges problem on this. Okay, someone also mentioned for us in the comment section that friction reduces the what? The efficiency, right? Efficiency of a machine, That tells that there is no ideal machine, right? In the real world, there is no ideal machine. No machine is actually 100% efficient. No machine has efficiency of 100%. We don't really have an ideal machine, but the concept of ideal machine simply means that a machine that has 100% efficiency, right? But friction will always reduce the efficiency of a machine. This is one of the disadvantages, rather, not how to reduce. One of the disadvantages of for the friction, rather, is that it helps to reduce the efficiency of a machine. friction helps to reduce the efficiency of a machine. It's a disadvantage. Okay, that means there's no ideal machine. No machine is 100% what? 100% efficient. Now let's solve the problem from our textbook here. Okay, the question here says that a car of mass Guys, please share the group link. Share the group link. Do me a favor by sharing the group link. Share, share, share. Let's keep on sharing. Let's keep on sharing. What is the time now saying? Let's keep on sharing the link. This is already 5:43. Let's keep on sharing the link. Let's keep on sharing. Please, have you guys shared? Have you guys shared? Have you guys shared the link? Have you shared the link? Please share, 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 share. For those just coming, you're welcome. Just keep on sharing. Just keep on sharing the link. Okay? Keep on sharing the link. Now we have a question here that says that a body of mass 4 kilograms undergoes a constant horizontal acceleration of 3 meters per second. The mass of the body is 4 kilograms. Then we are told that the body undergoes a constant horizontal acceleration. Now we are told our AX is giving us what? It's 3 meters per second square. Constant horizontal acceleration. So the question here is to calculate the resultant horizontal force acting on the body. Okay, acting on the body. Okay, calculate the resultant force acting on the body. This is very simple. So I think we're going to use the Newton's laws of motion, that the sum of all forces is equals to mass times acceleration of the body along the horizontal axis. So that simply means the sum of all these forces, the mass is 4, right? Times what? 3. This will give us our sum of forces to be equal to what? 12 what? 12 Newton. 12 Newton. Then the question says again, what will be the resultant force on the body when it moves with a uniform velocity of 6 meters per second? When it moves with a uniform velocity of 6 meters per second, what will be the resultant force on the body when it moves with a uniform velocity, right? Uniform, we are given a uniform speed. Our uniform speed, also known as what? Constant speed, right? Constant speed of 6 meters per second. What will be the resultant force on the body when it moves with a uniform velocity of 6 meters per second? Uniform velocity of 6 meters per second. Don't forget that, note that at uniform speed, or velocity, right? Acceleration of the body is equal to 0. When a body is moving with a uniform velocity or uniform speed, also means what? Constant what? Speed. That means the body is not accelerating. The body is not accelerating. Like just from our velocity time graph, Abi, if I have this here, from here we have what here? We have acceleration, right? The body is accelerating from here, right? At this moment we have a constant speed. That means from here to here, from this point A to this point B, the body is not accelerating. So we have a uniform speed here. So here A equals to what? A equals to 0 here. So the concept here is that whenever a body moves with a uniform speed, it means the body is not accelerating. AX or A is equals to 0. So the sum of all the forces becomes mass times what? Acceleration along the x-axis, which is equals to our mass is 4 times 0. The answer is what? 0 Newton. So at a uniform speed of 6 meters per second, there's no force. The force is equals to 0. Okay, let's look at example 2. Example 2 says example 2 says a car of mass 500 kilogram is moving with a forward acceleration of 6 meters per second. A car of mass 500 kilogram moving with a forward acceleration of 6 meters per second is acted upon by a constant resistive force of 800 Newton. Calculate the force exerted from the engine to maintain the forward acceleration. Okay, I hope you guys are following. I hope they are following. Please, if you are following, indicate in the comment section. Okay, someone else just mentioned in the comment section we have lubrication, one of the method of reducing friction, right? We also have ball bearing. Thank you for reminding me. Ball bearing. Good, good. Let's keep on commenting. All right. All right. Thank you so much for that contribution. Thank you so much. All right. A question here says a car of mass 500 kilogram. The mass of the car is 500 what? Kilogram. Moving with a forward acceleration. Acceleration there is given as 6 meters per second. We have to find, okay, no, is acted upon by a constant resistive force, meaning our frictional force here is given as 800 Newton. Calculate the force exerted. Calculate the force exerted from the engine to maintain this forward acceleration. Now, let me assume that we have a body on the horizontal axis. Definitely, this should be horizontal because we are dealing with a car, right? So we have a car here. Okay, the car is accelerating with this forward acceleration. Forward means it's going towards this direction, right? Positive. So we have the value to be given as 6 meters per second squared. Per second squared, right? The mass is 500 kilogram. So we are told that moving with a forward acceleration is acted upon by a constant resisting force. That means this surface is not a smooth surface, it's a raw surface. So there's a resistive force here, which is 800 watts Newton, right? Which is our FR. Okay, it's 800 Newton. All right. Okay, since it's moving, that means the resistive force should be what? The kinetic what? Frictional what? Force. Because the body is actually accelerating with a value 6 meters per second square. They calculate the force exerted from the engine. The force exerted from the engine. The force exerted from the engine, right, to maintain this forward acceleration. To maintain this forward acceleration. So let me put this force here. Let's say we have the applied force, right? This is our applied force. This is the resistive force, which is called the Fk. And Fk is what? 800 Newton, right? Now we are looking for this applied force. This is the force that causes this forward acceleration. Don't forget that when the body is applied with a force in this direction, the body must accelerate this direction. That means the applied force here causes a forward acceleration of 6 meters per second square. Then we are told that the frictional force that resists this motion is what? 800 Newton. Now, we have two forces that act along the horizontal components, which are what? The applied force and what? Frictional force. That means the sum of all forces will then be what? Applied force minus what? Frictional force all equals to what here? MAX. Don't forget. So all we are looking for is the applied force, right? So from here we can say that our applied force is equals to, here we have MAX. When we move our minus FK to the other side, it becomes what? Plus what? Plus FK. So from here we can solve for the applied force. That will give us FA equals the mass of the body is 500 rather. We have 500 times, we have our acceleration to be 6 plus our frictional force is actually 800, right? Is 800. That is 800, right? Okay, so the next is to multiply this 500 times 6. That will give us about 3,000, right? Of course, yes. Then plus what? 800. I hope you guys are following. From here, our MAS plus FK equals to what? FA. Mass is 500. Our acceleration is what? 6 plus our FK. So 500 times 6 is 3,000 plus 800. So the applied force is simply 3,800 watt Newton. Now, he's saying that the applied force is greater than the frictional force. If not, the body will not accelerate. The body can only accelerate when the applied force is far greater than what? The frictional force or the kinetic frictional force. Right? Okay, let's put this down. Let's see another example. Another what? Example. Put this question. Let's solve this question. Question says that a body has a mass of 2 kilograms. A body has a mass of 2 kilograms. A body has a mass of 2 kilograms. The mass is 2 kilograms. Calculate the force acting on this body that will produce a velocity of 3.6. Calculate the force acting on this body that will produce a velocity of 3.6. Velocity 3.6 meters per second in 12 seconds. Our time is 12. In 12 seconds. In 12 what? Seconds. We also calculate the force acting on this body that will produce a velocity of 3.6 in what? In 12 seconds. Okay. So we're looking for the force, right? This is a very simple case here. What we need to do first is to apply the Newton's second law of motion, right? Solution to this, you have to recall that force is equal to what? mv minus u, right? Over what here? T. Is that not? So for this kind of question here, we don't have our initial speed. So we're going to assume this to be 0, right? Okay. So that means our force here becomes what? mv divided by what here? T. So the applied force becomes the mass of this body is 2 times our speed is actually 3.6. Then divided by what? Our time is 12. Our time is 12. So let's calculate. All right. I hope you guys are following. We are going to be using our force equals to mv divided by what? T. Okay, because we have just one speed. So we'll make use of the speed, which is what? Our v. We're going to assume this to be what? 0. All right. Okay. So here we have f equals to mv divided by t. Okay. So let's calculate. We have 2 times 3.6. This is about 7.2. 7.2 divided by 12. Divided by 12. our force is equals to 0.6 Newton. Force equals to 0.6 Newton. Please, let's take note of this. Please, if you are commenting, if you're in the comment section, please comment. Or if you're online, rather, please comment. If you are online, please comment. If you're online, please comment. Those just coming in now, you are welcome. You are welcome. You are welcome. All right, guys. So I want us to look at one more example, then we can shut down for today, right? We can now shut down for today. One more example. One more example, then we can shut down for today. All right, so let's look at this question here. We have a body of mass 6 kilograms moving with a speed of 20 meters per second is suddenly hit by another body moving in the same direction, thereby changing the speed of the former to 50 meters per second. What is the impulse received by the first body? Okay, let's look at this question. A body of mass 6 kilograms. The mass is 6 kilograms. The mass is 6 kilograms, okay? Moving with a speed of 20 meters per second. That is our initial speed, right? 20 meters per second. Is suddenly hit by another body moving in the same direction, thereby changing the speed to 50. So the final speed becomes what here? 50 meters per second, right? What is the impulse received by the first body? We are looking for the impulse received by the first body. Okay, I repeat again the question. Question says that a body of mass 6 kilograms moving with a speed of 20 meters per second is suddenly hit by another body moving in the same direction, thereby changing the speed of the former body to 50 meters per second. What is the impulse received by the first body? What is the impulse received by the first body? Mass is given as this. Our initial speed is 20. Final speed is what? 50. Impulse. That's looking for impulse. Let's look at this. Look at this question. From Newton's laws of motion, Newton's second law, especially Newton's second what? Law of motion. We stated that force applied is equals to what? Mv minus u divided by t. Therefore, the formula we derive, right? By the time we cross multiply this, we cross multiply. We're going to have force times t to be equals to what? Ft, all equals to mv minus what? U. Hope you are aware that we call that force times t is equals to impulse. Is equals to impulse. Ft equals to what? Impulse. So that means impulse is simply the product of force and what? And time. By the time we cross multiply here, that will give us force times time, which is what? Impulse. So the product of force and time is what? Impulse. And also, impulse can be defined as change in what momentum of a body. If Ft is equals to impulse, that means that impulse is also defined as change in what momentum. Momentum means mass times what velocity. So if I have mass times change in what velocity, that means momentum impulse is what change in what momentum of a body. So from here we can see that our impulse is simply mass v minus u. So my impulse becomes what? Now we have all the parameters, right? Our mass is given as 6 times our speed. Our final speed is 50 minus 20. So our impulse becomes 6 times, right? 50 minus 20, that will give us 30. So 6 times 30, it should be about 180, 180, right? Yeah, 180 Newton seconds. Force is measured in Newton, while time is one is in seconds. So it will give us 180 Newton seconds, right? Or we can also say 180 kilogram meter per second or 180 Newton seconds. All right, we're going to stop for now. We're going to stop for now. Then we'll meet again, possibly tomorrow. We'll keep on meeting this way, like we just met. And for those of you who just joined us, make sure you go through all the classes. We started from friction, then we are comparing friction and the laws of motion together, right? So tomorrow morning we'll go into the third law of motion, then also look at friction along an inclined plane. Then we'll also solve more problems on what I explained today. Right there? On what I explained today, we'll bring more calculations, we'll tackle them together and all that. But please, if you are just coming, make sure you go through the video from beginning to the end for proper understanding. So that once we meet tomorrow, there will not be need of me starting afresh or trying to explain one or two things. I will just go straight to the point, believing that we all know the foundation. What we did today is just a foundation class in friction and Newton's laws of motion. In my next class, I will go deeper than this in my next class and we'll solve more calculation, we'll solve more problems. So guys, see you in the next class. But make sure you go to the class and share the link to others. After this class, I will download this video. It will stay remain in the YouTube in our channel so that you can always come back anytime to revisit and to study. All right. Thank you so much for those of you who have been online since 4 a.m. Thank you. I really appreciate. I'm encouraged for you to come online. I'm encouraged. Okay. Thank you so much. So our school class will be starting by 8 a.m. For those of you who would like to join us at EMI-BRAIN Tutorial College in Plaza. This is a global class actually, but I'm talking about those who reside in Imo State University. So we are inviting you to our class, our tutorial, our class. This morning we're having chemistry 101 and physics 101. Chemistry, we are looking at redox equations, reduction and oxidation, how to balance a redox reaction or equation. All right, so see you in class. Thank you.